Okay. Section 4.2 didn't get a highlight video either because I thought maybe I could just tell you what to highlight and you'd be okay with that. Pretty much self-explanatory since you've been highlighting for 3 chapters now. I bet you already know that on page 133, you're supposed to highlight the red box that talks about postulate 14, which is the side, side, side postulate. That's what the 3 S's stand for, side, side, side. And then on page 134, you have postulate 15, postulate 16, theorem 4.1. All of those are on page 134. They're all in red boxes too. I bet you figured that part out. Those are the things that need to be highlighted. SAS stands for side, angle, side. ASA stands for angle, side, angle. And AAS stands for angle, angle, side. We're going to talk about them so that you can understand what each of them is really talking about. And then we're going to work on a proof so that you can understand how we use them. So let's first start with purple. That's the one that I'm going to talk about side, side, side with first. When we're talking about side, 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 what that means is if you have these facts, then you can assume that the 2 triangles are congruent. So for side, 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 obviously that means that we are told that it has congruent sides. Now, it doesn't have to be congruent to the same triangle, but congruent to its corresponding side in the other one. That'll tell you that they have to be congruent triangles. Because all of these sides are congruent, therefore my 2 triangles are congruent. Make sure you list them off the correct way. So that's what side, side, side looks like. Okay? When we're talking about side, angle, side, that means that the angle has to be in between those 2 sides. So if I was talking about side, angle, side, I'd be talking about maybe this side being congruent to that side, this angle being congruent to that angle, and then this side being congruent to this side. I know I'm marking them up, but you'll be all right. The angle has to be included. The reason for that is if the angle is included, then this has to be only a set space, which means that if these sides are the same, just like it was when you're drawing stuff, then this can only be so far out, and it's going to create congruent angles, and that side's going to have to be the same as that side. So this one works, side, angle, side. Angle, side, angle means that the side has to be included in between those 2 angles. So if I were talking about maybe angle A and angle H being the same, and maybe side AB being the same as side HK, and this angle being the same as that angle. Now I have angle, side, angle, where the angle is the side is in between those 2 angles. Since that's the case, we know that both of these triangles must be congruent, because if we have 2 angles, we can predict that the other angle is going to be congruent, and if one of those sides is the same and all the angles are congruent, then our triangles would have to be congruent too, because that side is the same, they're not similar. Now, if the side wasn't the same, then we'd have to talk about, oh, they could be similar. But this time we have a common side. And then the last one we're going to talk about is angle, angle, side. Ooh, I need a darker color than that, I think. Let's see. Is this one really going to give me a darker color? It is. I need to get rid of that. No, not really. Fine, fine, fine. Patience, patience. Okay. There we go. So for angle side, we're talking about it having the same angle like it was with H. We're talking about it having another common angle, and then a common side that is not in between the two. But even though it is not in between the two, it has to be beside one of those angles. So since it's not in between, obviously it's going to be either one of those two. So it's going to be beside one of those angles. But when it's not an included angle, it will still work. So here I have angle, angle side, angle, angle side. And that works for the exact same reason that works. You got two angles in there. You know the third one's going to have to be a certain number because all the angles in the triangle add up to 180, so forth and so on. And all these reasons I'm giving you make really pretty proofs. What about angle, angle, angle? Does that mean that my triangles are congruent? No, it does not. It doesn't mean that they're congruent. They could be congruent, but they don't have to be congruent. What it does mean is that they are similar. So since they have all the same angles, that means that they have to be similar. It does not mean that they are congruent. Don't get caught up in that. I did when I was your age. I used that as one of my reasons and got marked down. I'm just saying it happens to the best of us. Okay, so I am going to set a proof up for us to talk about because I need to make sure you can do proofs with these. Okay, hold that thought just a second. Okay, so this is the proof I want us to talk about today. We're given a lovely picture. Ta-da! And they gave you two statements that AB is is parallel to DC, and that angle B is congruent to angle D. And they want you to prove that these two triangles must be congruent. So, let us begin. You always start a proof with what they tell you. So they gave us some stuff. The first thing I'm going to do is that AB is perpendicular to DC. I'm going to go ahead and put lines on that. So we're talking about the segments themselves. They're already marked over here on my picture, so I don't need to mark them, parallel. I keep saying the arrows tell you that they're parallel to each other. So my reason for that is that it was given. And then my second statement is going to be that angle A is congruent to angle, well, I can't just call it A, can I? Because there are two angles at A. Let me back up. Angle DAC is congruent to angle BCA, which means that this angle up here is congruent to that angle down there. But you know what? We don't know that. I marked the wrong one. Because what we know, it would be true if these two lines were parallel, but they didn't tell us that. They told us that these were the two that were parallel. which makes that the transversal, which means that this angle is congruent to that angle, which means I need to rewrite this. So instead of calling it angle DAC, I better call it angle BAC. And instead of calling it angle BCA, I need to call it angle DCA. And we know that because they are alternate interior angles of parallel lines cut by a transversal. But I'm just going to say we know it because they're alternate interior. Alternate interior angles are congruent. And now we have, in this triangle, two angles, and in this triangle, two angles. Can I show that this side in between those angles is congruent? Well, no. We can show that they're parallel. We can't show that they're congruent. So, since we can't say that, that makes me think, could I show this side and do angle, angle, side? And no, we can't get angle, angle, side because we don't know how far those are apart. But what we do know is that this side is congruent to itself. That this side right here is the same length as that side right there. We know that because it's the same line. So since that's the case, I can say that side AC is congruent to side CA, and I know that by the reflexive property. The one that we threw out last time when I was talking about it. And therefore, you like how that word, right? Therefore, what they asked me to prove, triangle ABC is congruent to triangle CDA. Now, if that's the case, triangle ABC going from my 2 marks to my 1 mark to no mark has to be congruent to CDA. 2 marks, 1 mark, no mark. So I know that my stuff is lined up correctly, but did I show this stuff correctly? Because you have to be very careful. So when I'm talking about things on the left-hand side, side AB and side DC, DC applies to that side of the triangle, and this side of the triangle is all for this one. So I need to make sure that the AC that I need from A to C is the one that's opposite B, which it is, but it goes from 2 to nothing. And that my CA is the one that's opposite D, and that it goes from 2 to nothing. So you need to make sure that you've got those flipped. You can't just throw them into themselves because that doesn't line up your triangle correctly. You got to make sure you have those corresponding sides lined up correctly. And we prove this by angle, angle, side. Now, when I was going through this, trying to decide which way we were going to prove these two triangles congruent, because that's what they asked us to do, I went through in my head and I was like, side, side, side. We don't have any sides, so we can't use side, side, side. And then I was like, okay, can I use side, angle, side? We don't have 2 sides, so we can't use that one. So then it became, what do we have? that would help us out. And we could get 2 angles. So then I started thinking about the ones that had 2 angles. There was angle, side, angle, and angle, angle, side. And you saw me try angle, side, angle and how it wouldn't work. So that left us with the angle, angle, side one. And that one did work. And that one was what gave it to us. But in my head, I'm always constantly coming up, okay, how do I make this work? How can I make sure that this is correct? Because you got to be very exact with these things. So I hope that is clear as mud. So for your homework, I like it. For your homework and classwork, you have numbers 2, 6, 10, 14, and 18. And yes, the answers are in the back. And for your homework, you have numbers 4, 8, 12, 16, 20, and 27. And it is on page 136 and 137. Told you the answers were in the back, right? And it's a practice exercise. I had to get it all in there. Okay, you'll see me tomorrow or day after tomorrow, wherever we ended up. I forgot now. But you'll see me. It'll happen. Bye.